here we want to ask a different question. We know a butterfly can cause a tornado, but can a butterfly control the climate? Causing a tornado relative to controlling the climate is easy, right? For example, here I'm showing you the 10-minute precipitation time evolution of the United States over, well, a month. And as you can see, even a tornado is probably just a blimp in the precipitation dot of the weather. If you average the precipitation over decades, what you get is the precipitation map you see on the right-hand side. This is the kind of climate we are talking about. In this talk, I'm defining the climate as the statistics of weather over a long time. Or in the case of unsteady flows, it is the statistics of the flow field. For example, if you have turbulent flows, we are looking at the statistics, the mean, standard deviation, the probability of certain events, right? That is the kind of climate we are talking about. And the question is, can a butterfly control the climate? Or can tiny perturbations dramatically change the statistics of a chaotic dynamical system? Right. This is the kind of question I'm asking today. And what I want to do is I'm going to outline, first of all, what's the consequence of this question, right? I mean, this, of course, the question sounds unlikely to be yes in the beginning. I mean, how can such a tiny perturbation change the climate, which is more difficult than just changing the weather, right? And I'm going to outline the arguments for answering the question as no and for answering the question as yes. So first of all, why is this question important? If the answer is yes, what if a butterfly can control the climate? The kind of chaotic simulations we are doing, for example, this is a large eddy simulation for analyzing the heat transfer on the turbine blade. This is very important because a steady state Reynolds average Navier-Stokes cannot reliably predict the heat transfer. So you have to run turbulence resolving simulations. The problem is that once you run such a simulation and predict the heat transfer coefficient, which is a statistic, right? The average amount of heat that goes into the turbine blade, that's a time average, that's a statistics of the turbulent flow field. And the question is, can tiny numerical errors, not to mention modeling errors and truncation errors, these are tiny perturbations. However, if these tiny perturbations can dramatically change the turbulent statistics, then how can we trust these simulations in making engineering decisions? Right? So this is a fundamental question in the validity of any type of numerical simulation that tries to reproduce or tries to predict the statistics of chaotic dynamical systems, including many turbulent flow fields.